The broadcast is now starting. All attendees
All
are
right,
in
welcome
listen-only
to the
mode.
Enterprise Readiness, What, Why, and How It Matters to Rescale webinar. I'm David Anselmi. I'm the Director of Product here at Rescale. Rescale provides HPC in the cloud. Let me give you a little précis of what we're doing today. Our journey today is Enterprise Readiness for HPC in the cloud. Step one is, what is Enterprise Readiness, and why do we care? Enterprise Readiness includes enterprise grade, your security, your robustness. Robustness is availability, consistency, your support in your SLA, your service level agreements, your budgeting, reporting, your user management. Who needs enterprise readiness? Well, enterprises, of course, but what about startups, let alone HPC, high performance computing? The next is, can a startup provide enterprise readiness? Startups provide speed and flexibility of execution. You can get a lot of things done quickly. However, as one large startup, which has become an enterprise now, calls it, moving fast and breaking things, does that actually work with enterprise grade and readiness? And finally, how does Rescale itself provide enterprise readiness? And I'll describe a little bit and walk you through our current platform capabilities and our recently released enterprise features. So we'll start right here. What is an enterprise? This dates me. I had to put it in. Let's see. So more specifically, what is enterprise readiness and why do we care? I'm going to use a model by a site called enterpriseready.io. It is a freeware site. It allows you to do an assessment of your SaaS platform, your software as a service platform. It does it on multiple different dimensions. Let me go through a handful of them that are important to enterprises. The first one is security. Security is combined in multiple things. Let me call out three of them. RBAC, which is role-based access control. It means that I can control my users' ability to access different things, modules, software, applications, physical compute devices. So the role is, like, for example, this user is an administrator. This user is a buyer. This user is an engineer. And I can say this user has read, write, view, update control over different particular resources. Enterprises get super granular about this. They can have RBAC on the data level, so I have the ability to view or update or modify, update and modify the same, delete for the actual data, but I have a different control for the actual viewing of said data depending on its method. So I can have SSH control or API control, or I can have viewing the actual data on the UI. So you can be easily in a state where I have the ability to view the data on the UI, so I update a web page. It happens in Salesforce all the time when people do their implementations. But the actual web page, the page loads, and there's nothing on it because they don't have view to the actual underlying data. So this is the kind of granular control an enterprise wants, because then it allows people to say, oh, you can update this data element using this form of access, but not that form of access. And you can view it using this form and not that form in this location and not that location. SSO is single sign-on. This is the ability to allow the users to not have to juggle billions of passwords. An enterprise is going to have multiple different platform and or projects and or systems that the user needs to access to do their job. And in so doing, if every one of those systems needs to be secure, and they do, and they need to access them, and they do, then you're going to be juggling billions of passwords. So what the enterprise absolutely requires now, it's no longer a question, it's absolutely mandatory, it's table stake, is the ability for the user to have one login with one password, and it automatically provides credentials to all those bespoke systems. Integrating to different SSO systems has always been a trick. Right now we have a couple of kind of standards out there from Google and from Facebook, but those aren't nearly secure enough for some enterprises, so they want even better ones. And then SOD. SOD is segregation of duties. This is the ability of the system to actually say this role is allowed to do X and that role is allowed to do Y, and no one user can have both. The classic example is I can create an expense report and I can approve an expense report, and one user should not be able to do the same thing with the same expense report. So having that set up in the system with an automatic periodicity of reports, and to be able to confirm the system is not allowing people to do accidental things, because it's, one expense report, big whoop, but what if it's millions of dollars of PO? So having that system running in the background and auditing automatically is a big part of some compliance frameworks and security attributions. Budget controls. Can you control the amount of spend used by the system, or at the project level, at the user level, at the account level, at the whole company level? And can you control it, for example, at strict level? So in the middle of your job running, you run out of budget, kill the job flat, or allow that job to finish, but no more jobs to be launched. Change management. Making sure that the system keeps control and logging of everything that occurs. So when a user makes a modification, especially a big modification to either data or availability of modules or whatnot, the system keeps a record of that. Now there's a necessary tension here, because if I do, the more verbose my logging is, the more the system could potentially be slowed down, and definitely the more data I'm actually capturing. And so many systems will capture very fine-grained detail for only a short length of time, maybe 24 hours, and then they do roll-ups and aggregates of that, which gets stored for the longer term. So how do you maintain, if I have a need to audit, what the user does on a very, very fine-grained thing months and months later? So being able to capture fine-grained detail for an audit controls really matters to enterprises. User management, I already mentioned this before, the ability to make sure that the right users are using the system and the wrong users are not, and control that through role-based access control. Ad hoc reporting and alerting. What happens is an enterprise is gathering huge amounts of data and making that data work, i.e. turning raw data into useful, actionable information, is the critical bit. So can you allow and make it easy for the user to access the system, pull reports out of it, ideally with graphs and things that look pretty, so they can go tell other people, hey, this raw data actually means something. And finally, after you have all this, all these complex different moving parts, can you make sure this entire system is easy to deploy? An enterprise already has tons of systems. If your wonderful solution for them is simply come in and drop everything you have and replace it with ours, you're going to get flat nowhere. They want to make sure that their system works well with yours, so plays well with others is an important part of enterprise readiness. All right, let me put this in a little bit of actual example. I worked at Oracle for quite a few years, so let me give them as an example. The Oracle Relational Database Management System and its financial suite. So the perception is Oracle's got 5,000 developers, thousands and thousands of modules, and it's extremely complex. They have highly paid database administrators and implementation teams, and it's very expensive. For many people, it's overkill. Those terms have actually been hinted at in Gartner, for example. But the reality, Oracle is the most powerful relational database system on the planet. Oracle Financials ERP, ERP is Enterprise Relationship Planning or Enterprise Resource Planning. It's the reference model for ERP, which means that if you have an enterprise level workload of structured data or huge amounts of money and you're moving it back and forth, your system absolutely must be able to speak to Oracle Financials. So everyone moving serious amounts of structured data or the corresponding money, they have to be able to integrate with them. And that includes startups wanting to become unicorns. And let me just put a little proof on what I'm describing. This site's pretty useful. I've been using it for lots of years. dbengines.com, it's be able to tell you who's using what around the world. And it's not just the install base of the server software, but actually users and how much money is going through the system. And Oracle and SQL Server right there at the top. And yes, MySQL is there too, but that usually isn't an ERP system. That's typically because MySQL is built into the LAMP stack, and it's mostly content management systems are using MySQL. Yes, there are a lot of startups that use MySQL, but typically you replatform and migrate away when you get to huge amounts of data because MySQL doesn't scale very well without sharding. And sharding kind of ruins the whole point of having a relational database management system and asset transactionality. Another way to look at this is when I think of an Oracle, I think of a mansion on wheels and it moves really slow. But many people don't realize it also can do this, 333 miles per hour semi-truck. So being able to move a huge amount of data really fast with a lot of rigor, that's what you're paying for a huge complex system, or in other words, an enterprise. So who needs this enterprise readiness? Well, enterprise, of course. And what does that really mean? Your enterprise grade is kind of the stamp of approval. You've got your quality control, your consistent experience, your robust availability, your complex user cost controls, your security controls, and user controls. Let me describe some verticals. So you got aero, which aerospace, automotive, financials, healthcare, but more specifically, high-speed aeronautics, high-speed auto like Formula One, high-speed aeronautics like supersonic jets. Anyone operating in a regulatory environment. I used to work at Bayer, and we literally say, can people die if your product fails? Or specifically at Bayer, are you putting something in someone's arm? If you're doing that, and people can absolutely be materially, instantly affected by your system better be as robust as possible. Now, what about startups? Startups are more flexible. They can be more flexible about user controls availability. If the system kind of goes down for a little bit, startups are often okay about that. If Facebook drops some of its service and now you can't update somebody's wall, nobody's going to lose and get stuff put in their arm. Nobody's going to die from a wall entry not being there or getting updated slowly. However, if you do a banking transaction, then money could be lost. Or if it's a smart hospital and they goof on that, somebody can get the wrong drug at the wrong time. Startups also very much appreciate security controls and cost controls, but often they don't want to pay for them, but they will absolutely use them. But that necessary tension, moving fast and breaking things, how do you relate that with robustness, availability, and quality? So enterprise readiness for HPC, what does that actually mean? Why does it matter? HPC organizations, you might not realize, already have some level of enterprise readiness. The on-prem HPC system is already leveraging the back-end user controls and cost controls. The data center manager or the IT manager, whoever set up that cluster, gives access to it through the on-prem LDAP. And so the user is going to log in and go through the system and have different rights associated with them. And they're already leveraging that kind of enterprise stuff. You just don't think about it when you're using HPC. Just give me my login, let me submit my job. Don't worry about all the other baggage. But the baggage is there. They don't want the wrong people using that system because it's really expensive. The on-prem HPC also inherits security via isolation, which means that cluster is not connected to the internet. No one's going to be surfing the wrong site. No one's going to be on the web pinging that cluster and saying, hey, look, I can run this job on this $40 million cray. There's no way you can access it. Also, on-prem HPC has quality control, consistent user experience simply because it's extremely expensive hardware. They literally designed to never go down, so they don't have to worry about checkpoint restart at the software level. Now, HPC organizations, though, are starting to realize that they're going to need the cloud. The cloud's going to be able to give you burst. It's going to give you best-of-breed hardware in between their buying cycles. It's going to give you geo-distribution so that even though you have this really great cluster of $40 million for a cray, but it's over here in the EU, and I need it in the US, or I need it in AP. So enterprises, or rather HPC organizations in enterprises, are going to need enterprise readiness cloud when you use HPC in the cloud. So that means cloud HPC needs to provide the user controls and cost controls. They need to provide security and isolation, especially across geos. They absolutely need to provide quality control, consistent experience across multiple cloud providers, and provide a geographic distribution of that data. So how does Rescale provide all this? So if you will, HPC in the cloud, the challenge is met. Security. So we isolate your enterprise agreement. So if you come to us and say, hey, I got an agreement with AWS, I got an agreement with Azure, what we'll do is we'll say, fine, we'll leverage that agreement. You run your job on us. We'll deploy the job into your EA. So now it's using your own system with your own accounting, your own billing, your own security model, your own IAM, your identity access management, all those things that you've set up at the enterprise level, enterprise grade, is all being leveraged. Similarly, we set up VPNs and private networking. We also do everything with encryption at rest and in motion. Our security accreditations include GDPR, SOC 2, we're HIPAA ready, and we're in the final stages of FedRAMP ready, which is pretty extraordinary for a startup. Also, for the robustness, which includes availability, consistency, examples like this, we have checkpoint restart at the software level. Now, if you're at the hardware level, it's very easy to checkpoint restart. You can just grab state on the physical machine and everything on it, and then you bring the machine back up, and all the software, even the variables in flight in the stack, go exactly where they started. But as you know, the cloud's nothing about that. Not only we don't have control of that hardware, we really don't know what the hardware is under the hood because LMUtil and this CPS util are not going to tell you exactly what's underneath that hypervisor. So what we do is we figured out how to do software checkpoint restart. So we ask the software, please throw a checkpoint. We capture the entire state as much as possible. We capture the whole thing up and bring it up on a brand new node, and the software doesn't know it moved, and it comes right back up again. So we can do this on very large clusters, and we do it all the time for when people are leveraging what's called the spot market. That means they are willing to trade time to result possible extension for a lot cheaper compute. But the trade-off for the cloud is they are willing to pay you or let you pay half as much or even less for that spot instance, but they don't give you a guarantee of service, so the spots might be pulled out from under you. So to make that trade-off work for you and save a lot of money, you have the possibility that your job gets restarted. But we're not going to restart it from scratch. We're going to restart it from where it stopped. We also provide cross-region provisioning and auto-balancing. That means your actual jobs will get deployed across the different regions to make sure that we're not overwhelming any particular region. And again, this matters with Spot because if you grab too many instances of Spot simultaneously, you can actually bring down the spot market in that region. Cross-provider deployments. We also provide that as well. We literally working with several companies now so that when they deploy, for example, on AWS and they start to surge in a specific region and they want that region or something nearby for compute, and we've already grabbed as much out of AWS as you can possibly grab before the spot market changes, we're going to grab something in Azure or the other way around. We also provide version controlled software and operating system images. So that means if you say I ran this at this point in time and I want to go back X amount of years and run the same thing at this similar point in time, as long as the underlying hardware on the cloud is available, we can do that. Now, to do this kind of in a regulatory environment on-prem, literally people grab the original hardware instance and lock it in a closet and bring it back out. We can't really do that with the cloud, but a lot of these instances stick around for 5 to 10 years. Usually it's 5 to around 7, so we can provide that for you for that version controlling. For software and service level agreement, we can relaunch your spot killed jobs at a non-spot at a discount. And we provide, when we do that, a better SLA than the cloud providers themselves. For budgeting, we have strict and non-strict, as I described. That means when you're launching a job or running your job and you actually consume the budget, we either kill it immediately if you set it at strict, or we allow that job to complete at non-strict. That's control of the user, the project, and the account level. And then finally, for user management, we have user group management of resources and role-based access control. So let me describe a little bit more detail about what we're actually doing currently and recently released features on the cloud for Rescale. The first one is region zone preference. So cloud regions have varying pricing. So you as the enterprise user or a regular user saying, hey, I want to run my job, but I don't want to pay more than X. So I'm willing to be flexible about the geographic location it runs in and be able to pay less. And that means that if I run my job at a distance from me, and depending on how big my input files are and definitely how big my output files are, it's going to take a little bit longer to get it started and a little bit longer to get it back if I'm running everything in the cloud and I'm going to bring it back down to my actual location. You can also just run it remotely, leave it there, and spin up what we call a VDI, a visual display interface, or a desktop. And you can actually view and modify your data remotely. It's kind of like VNC or a remote view, but the remote view actual software is running on a GPU, and it's called Nice DCV, and it runs really well and fast. So you can do 3D manipulations to your actual software in the cloud and not have to move the actual interim results back and forth. So you can do pre and post processing in the cloud without the latency of moving data. Bring your own IAM instance roles. IAM is specific to Amazon, but we support this on Azure as well. It means identity access management. If you as an enterprise already have an agreement with Amazon, if not Azure, and you say, I already have set up and modeled and profiled the way my system and my users work and integrate, rather than having to reset that up with us, you can just say, hey, leverage those. So you can leverage your own IAM integrations already. Custom username for compute nodes. This allows that your cloud instances, which auto get generated some weird names, are integrated with actually your on-prem compute resource namespace. And that means when you do reports, it doesn't stick out like a sore thumb. You can actually do very useful reports when the namespace is consistent. Prevent outbound connection from compute nodes. So allow HPC jobs to be revisioned, run, and the results retrieved in complete isolation. So the financial services market pay an awful lot for that. They bootstrap images onto nodes, and each step of the way there's huge amounts of handshake and massive security model to make sure that there's no way that the wrong thing gets deployed. We can provide you step by step exactly the same thing. So you can deploy, run the image is confirmed, stick the image there, get the bits installed. Every step of this way is not connected to the public internet. It's only connected to our provisioner, and then our provisioner disconnects and the job is to simply run. When it's done, the output files are sent directly one way to S3, and we still haven't touched it, and then the keys are available to you to go look at the data. We increase the file multi-part upload speed and robustness, which means that for huge amounts of data, you can do it in parallel, and making sure that it resumes and making sure that you never waste time if the cloud has a hiccup. The ability to selectively disable data interactions. So rich features often leverage the internet. For example, live tailing. If you want to be running your cluster and then you log on into our web platform, you can be looking over in the browser and watch the streaming data from the log files from the compute cluster. So doing that, though, it does hit the public internet. So you can decide, hey, I don't want to hit the public internet. Let me remove that particular feature. I'll be a lot more secure. And finally, bring your own SNS, simple notifications service notifications. That's another Amazon specific, but what it means is you can publish and subscribe to our SNS framework for when we deploy things on Amazon. And what that means is you can be directly notified on specific platform events and leveraging your own cloud integration. That means your own DevOps systems, your own reporting framework. Let me take a minute just to take a look at actually what our platform looks like, the Rescale Enterprise Readiness features that are available right now. So when you log into the enterprise level of our site, you're going to see a dashboard. The dashboard has the core utilization, the hardware usage by core types, top storage by user. You got charges. You got dues by day, dues by continuous. You can look at it at the month level. You can look at it for multiple months. And then when you pull down the platform, there's platform settings. You can set what jobs are run. You can set controls on clusters. You can set controls on what hardware. That means what core types, what instances on which clouds are being run, what softwares. We've got more than 300 different softwares you can decide. You can do default post-processing. For example, if you want to do an optimization framework and you want those always run a specific job type, you can set it here. You can have storage and transfer limit controls, meaning that a user can or can't use this amount of data in a certain amount of time. And then again, strict and relaxed means I can either stop them and delete the data out, or I can just give them a warning. For team management, I can set who's in my group, who's allowed. I can invite them in. I can set them in a group. I can set them in a project. And when they're in a project, I can do things like budgets. I have my summary reports for the billing. I can do purchase orders, and I can, as the user of a company, I can say, here's my purchase order to Rescale, and so I can start decrementing against it. I can also transfer deposits from, for example, AWS. I can get credits back when I actually get credits from AWS and I put them back in the system. I can manage my AEUs. That's ANSYS Elastic Unit. This is being able to purchase ANSYS and this specific software fleet of different HPC softwares. It may be able to purchase their on-demand units of tokens and be able to manage it directly here. On the security, the audit log we were describing, IP access rules, so we can control it at the row base, or we can actually control it at the IP. Multi-factor authentication is built in and turned on by default. Our password policy is set really high. You have single sign-on that you can leverage directly through Google, different SSO providers, or Rescale provides its own LDAP password, username and password, and notifications that you can set up. And finally, with integrations, we have license proxies, which means that a compute cluster running an HPC software wants to think it's on-prem. And so if your license server is not on-prem, we will connect to it remotely. And so license proxy simply means you proxy that connection directly. And so the cluster that's actually running the software connects right to that on-prem license server, but it thinks it's running in the cloud. However, enterprises sometimes they're not as comfortable with that, so we just use we also have the option of a direct VPN. So we have a VPN connection, the compute cluster connects directly to the license server. Now, why would you do all this rigmarole? Well, because ISVs are going to give you a better discount if you run everything through a license server rather than doing it on demand or separating out your license server. Because if you do have a separate license server, you give us that license file, we can host it for you. And that's the easiest way to bifurcate your usage between on-prem with its own license server and we run on your other license server in the cloud. But if you want to leverage everything together at the same time, we use a license proxy or a VPN. And then finally, the bring your own Azure, that's the bring your own enterprise agreement. We have that integrated deeply with AWS, and you can just go click here and add the username and password and your secrets and allow us to connect to your Azure enterprise agreement. And from there, we're going to deploy nodes for you directly into your own enterprise agreement or enterprise account on Azure. So with that, do you have any questions? So the question is, do you guys provide a virtual machine-like environment to set up, run, and post-process simulations? So say I want to run OpenFOAM from the GUI, moving results back and forth is not desirable. Absolutely, yes. So there's two different ways to do that. You can ask for a single node or a cluster, and that will be, like for example, you can have it with OpenFOAM on it, or for example, if you want a version we don't support, however, we've got a ton of versions. But if, for example, you want OpenFOAM and you're licensed to use it, then you can run a cluster. And for example, it can be a flat cluster with CentOS on it, and you can install it yourself. Or you can ask for a cluster with OpenFOAM on it with the version that you want. And then once you say, here, I drag and drop on my UI to the actual input files, and it'll run them there. I can do pre-processing there directly. And then after it's run, I can set up an optimization framework. However, if another way of doing this is you can set up what we call the VDI, and you can have a single node as a desktop running this if you want to run it that small, or you can have a single node connected to a cluster running a desktop. And now I have a of 3D version if you want, if OpenFOAM supports that. I don't know offhand if it supports that, but what you can do still is a VNC-like session I can actually watch directly as the thing is running. So what I can do is not only I can set up, I can run it, I can do the post-processing and drop the rest of the compute nodes and do post-processing and then launch a new job with that data. And depending how big your data is, that latency back and forth between what's called the object store at Amazon would be S3. The latency there, if you got huge hundreds of terabytes, you don't want to wait for that. So you can buy what we call a hot storage. And so your job is running directly on an inertial set of a fast disk. So now I can connect another desktop, I can connect another cluster to it. I don't have to wait for round trips to an object store, and definitely don't have to bring it back to yourself. So it's a good question. One of the biggest things after security on the cloud is, if I'm moving data back and forth, how do I deal with it? What you just described is a really cool case of a remote desktop view. And we now have the ability to not just do that on a single node, but the cluster itself can have the desktop running as its MPI head node. All right, another question came up. See, other than security and robustness, this person's heard that the cloud doesn't really compare the quality of HFC clusters to get on-prem. So show me that you get some good hardware there. And I have to say that's a really good question. And before I came here a couple of years ago, I would have said, yeah, that's a good point. But actually, at this point, you can get the fastest x86 chips, Skylake, on every major cloud. And that runs with the fastest interconnect, for example, InfiniBand on several of those clouds. In fact, Azure is in the process of enabling Skylake with InfiniBand as we speak. It's expected to be live in Q2, and Rescale provides access to on-prem supercomputing clusters as well. So if you want to run the fastest compute with InfiniBand on bare metal, that is available as well. Another question is, what's your typical cluster size? That is a really great question too, because on the cloud, first of all, hey, do you have the good enough hardware? And the second one is, hey, is this all little bitty nodes? Well, turns out for many CFD workloads, for example, we're seeing around 600 cores, which for us means 30 nodes of 20 core cluster. Now, to be brutally honest, the cloud, they'll say it's a 40 vCPU, virtual CPU, but it really means a thread. And we believe that's half of that's real. So it's not, the hypervisor isn't as clear as possible, but this is pretty much standard practice. If the hypervisor claims there's 20, or in this case 40 vCPUs, there's probably going to be 20 physical cores. So we're going to call a 40 vCPU instance a 20 physical cores. So for 600 core cluster, we're going to get 30 nodes of a 40 vCPU machine. And we've seen that run, for example, all the time. Multiple days, they just run, they're absolutely run. The only time those things go down is if somebody did it on spot, and if you run multi-day on spot, you're gonna probably hit a spot retrieve, especially with when you have a surface area of 30 nodes. So again, that software you're running, you make sure you've clicked on that it does checkpoint restart, and when it gets restarted as a new cluster, it's gonna continue where it left off. We've successfully run 1,000, 2,000, even 4,000 core clusters on the biggest clouds out there for multiple days. It all depends on your workload, how much internode traffic there is, and how much memory, how well the memory is architected, and most importantly, the latency levels. Basically, the size of the cluster is about the lower the latency. If you have a very chatty protocol, and MPI is often very chatty, if your interconnect is got a low latency, you can really scale that out. If it doesn't, you can't. It's as simple as that. I think we're getting there. Let me do a quick update here for what are we working on next for Rescale for Enterprise Readiness. There are two things coming out in the near term. The first one is a single email ID can be associated with multiple accounts. That means you log in with a single email and you say, hey, I want to work as this user type of this system or this user type of this system. This is something an enterprise does all the time, depending on what hat you're wearing. Right now I'm a buyer, right now I'm an approver. But again, with segregation of duties, I can't buy and approve the same thing. Right now, I'm an administrator or an IT system admin for a specific HPC cluster, but not for the other cluster. The other thing we're going to be doing is provide, when you have multiple different accounts associated with a single company, have those accounts be hierarchical. So this account inherits properties, settings, and metadata from that account, but not from another account. So to be able to do that, you can model an enterprise that goes over worldwide. And so it allows the account hierarchy to model different seller and value-added distributor agreements, different company operating units, and different geos. So with that, I really appreciate your having some time spent with you today, learning about how Rescale works with enterprise readiness and why enterprise readiness is useful to HPC. Thanks a lot, and always be sure to reach out.